to talk today. I was just saying it's very, very nice to have these opportunities just to meet some new people, even virtually. So that said, I'm very happy to present my work on the Ebola epidemic and relationships with prominent affiliates. Okay, so in the year 2000, Christian Happy, shown here, traveled from Nigeria to the United States to carry out a postdoc position at Harvard. And it was there that he met Pardis Sabeti, also shown here, who was studying at Harvard as well. So following his postdoc, Christian went back to Nigeria and he established an infectious disease laboratory at a small rural university in Nigeria. A decade later, he and Pardis, who is now a professor at Harvard, won a large World Bank grant to establish a joint international genomics center to be located in Nigeria. And soon he had a state-of-the-art genomics laboratory. So now he hosts frequent visitors from Harvard. He sends his own students to Pardis' lab for training every summer, and his lab is globally recognized as a hub for good science. And in fact, in January 2020, Christian and Pardis gave a highly viewed TED Talk on how to prevent a global viral epidemic. So on the left, you can see the state-of-the-art equipment for genomics research in Christian's lab in rural Nigeria. But on the right, just a few hours of drive away, is another genetics lab at a different university in Nigeria. So this one has no equipment, no electricity most of the time, little publication output, and definitely no international visitors. I think I was the first they'd ever had. And so, of course, while Christian Happy is obviously a superstar, the case suggests that this relationship with Pardis and her status as a Harvard professor could have played some role in his rise in the global scientific community. And in the same thought, with these researchers at the under-equipped university in Nigeria just unlucky to have never gotten that first tie with Pardis? Or does Christian have something that enables him to leverage the relationship and rise to his own stardom? And so in this paper, I ask, what is the causal value of an opportunity to build relationships with prominent affiliates? And what drives inequality in the distribution and the leveraging of these relationships? And I studied this question through leveraging an unanticipated opportunity to build relationships with more prominent affiliates that was afforded to some African scientists and not others. So the 2014 West African Ebola epidemic provided endemic country scientists with an unprecedented opportunity to build relationships with foreign scientists flooding into endemic countries, searching for local collaborators and attempting to carry out Ebola research on the ground. So I use publication data of endemic country scientists to compare the changes in outcomes before and after the epidemic to that of matched control scientists in non-endemic countries in a differences framework in order to assess the impact of this opportunity to build relationships with more prominent affiliates from around the world. So just a quick preview of my results. So I find that following the Ebola epidemic, endemic country scientists experienced a 6% annual increase in quality adjusted publication output as compared to matched control scientists in non-endemic countries. But this average effect masks some striking heterogeneity, and I find that this increase in productivity is driven by endemic country scientists who had prior knowledge relevant to Ebola and prior connections. And therefore, the inequality amongst endemic country scientists actually increases as a consequence of this international attention during the outbreak. Okay, so just a quick roadmap of today's talk. So I'll go into some background on why I'm asking these questions, then I'll get to the setting and empirical design, and I'll present some results and conclude with some finishing thoughts. Okay, so why am I asking these questions? Well, scientific activity around the world is highly skewed even after adjusting for relative differences in economic activity. And so in an attempt to explain this skew in scientific activity, I'm considering science as a global system with, for the most part, pooled inputs and a shared audience around the world. And this is particularly true for African scientists who have little to no domestic funding or outlets for science. They're really reliant on the rest of the world. And so one pooled input worth thinking about is knowledge. If we think of scientists as standing on the shoulders of other scientists, the global production of knowledge acts as a crucial input into subsequent knowledge generation. But knowledge doesn't flow or travel very well over geographic distance, and particularly over national borders. And so for those scientists and innovators located far away from the dominant producers of knowledge, this can create additional barriers in accessing this crucial input into the ideas production function. And compounding these difficulties associated with geographic distance from the dominant producers and users of knowledge, I also argue that there's a global status ordering of scientists. And so why does this matter? Well, this picture depicts the early academies of science, which reserved just 40 chairs for an elite group of scientists. And the members of this exclusive invisible college also benefited from superior access to knowledge, resources, and recognition as a consequence of their status. And so for those outside these exclusive circles, it can be a challenge to access the necessary factors of production to do good science. And Merton accurately described this system in the 60s when he said the rich get richer and the poor get poorer. And so if location determines relative position in the global status ordering of scientists, and this in turn drives access to knowledge, resources, and recognition, this could account in part for the observed skew in scientific activity around the world. And with African scientists by many measures less elite than their global peers, this could present some additional challenges in improving their scientific performance. And so one way to overcome these disadvantages of stratification that social or physical outsiders may experience is to develop relationships with insiders who can, in theory, share their advantage. And in the global system of scientists, this could be scientists from high-income countries. And African scientists have the highest rate of international collaborations in the world, with around 80% of their African publications co-authored by extra-regional collaborators, particularly collaborators from OECD or high-income countries. I see there's a question, but maybe I'm not supposed to look at it. You can interrupt me anytime.
No, it's not a question. Go ahead, please.
Okay. So prior literature has theorized about these possible benefits of relationships with more prominent affiliates who can, in theory, share their advantage, either by sharing knowledge or resources or transferring their status, in fact, to their affiliates. And prior literature has documented a link between these relationships with more prominent affiliates and performance across a variety of settings. Okay, but this literature is just based on observational evidence and observes outcomes of those who already have these observable relationships. So this leaves us two main questions for us to answer. So first, do we actually know the causal value of these ties if they were to be assigned randomly across the population? Or do these estimates that we have suffer from some omitted variant bias or a reverse causality? And sort of more generally, do these relationships actually drive a wedge in between underlying quality and outcomes of an actor and set in motion the principle of cumulative advantage, increasing inequality? And second, we know very little about what might actually drive inequality and who has these relationships, because we only observe them for the people who already have them. So certainly these relationships aren't ubiquitous around the world, in part because high status actors have incentives against forming such relationships. If we think these relationships are all about transferring status, the converse logic applies for high status actors. They may, some of the low status actors' status may leak onto the high status actor, which is a bad thing for them. And so one question remains around the distribution of the relationships is it just luck in determining who has them? Is it sort of a good opportunity? Somebody gets once and then they're all set. Or is there something or an ability to leverage this luck or an opportunity that drives observed inequality in the distribution? And so in this study, I explore this tension and I ask whether actors benefit from an opportunity to build relationships with more prominent affiliates. And I argue that even once provided with an opportunity to build such relationships, features of an actor can limit their ability to take advantage of this opportunity or this new tie. And I explore this in the context of global science, where collaborative ties are particularly important for sharing knowledge, resources, and recognition.
All right, sorry, just a quick clarifying question from Gaetan. He would like to know how the figure of publication quality and quantity was constructed, what was the data source, and how quality was calculated.
That's not my, so that's not my figure. That's from a source called something soup, and the quality is their own quality metric. I can share it with you afterwards, if that's okay.
Okay, sorry, it's from Jean Lin Wei, not Gaetan. Sorry for the confusion. Thanks for the clarification.
Okay, but any MAC that you see of global science, whether it's just quantity of publications or Nobel Prize distribution, it looks pretty much the same. It's concentrated in Europe and North America, and Africa and parts of Asia have very little scientific production. But that one's based on quality of institutions by an institution ranking that this, what's it called, scholarly soup creates. Okay. So in particular, there's reason to think that prior knowledge might affect the ability to leverage a new tie in the setting of global science, because relationships, and in particular collaborations, are founded on some shared interests and mutual intellectual contribution. So a scientist with more relevant knowledge to bring to a new relationship is more likely to be able to leverage an opportunity to build relationships with more prominent affiliates. And second, there's reason to think that prior connections could affect the ability to leverage a new tie in the setting of global science as well. So uncertainty in global science about actors and their quality makes shared norms and referrals extremely important when scientists are deciding to develop new relationships. I think we all understand this concept quite well. So therefore, two actors who share connections are more likely to make a long-lasting relationship than those without such mutual connections. So the logic follows that if a scientist has shared connections to more prominent affiliates already, they're more likely to be able to leverage an opportunity to build relationships with subsequent prominent affiliates and convert this opportunity of a new tie into a long-lasting advantage. Okay, so those are my hypotheses or my propositions, but testing these propositions is really difficult. So the features of an actor that determine their opportunities or their relationships are likely to be the same features that determine their outcomes. And so inferring a causal relationship between the two can be a great challenge. And so my identification strategy to explore these questions, so the impact of an opportunity to build relationships with prominent affiliates, I exploit the geography of the Ebola epidemic. So I'm sure you all remember or have unfortunately familiarized yourself with the 2014 West African Ebola epidemic. This epidemic garnered international attention. At the time, it was one of the most catastrophic epidemics that we've seen in our lifetimes. And around the world, science was touted as the solution. So scientists and funders were searching for therapies and vaccines in particular. And funders and scientists, particularly those from OECD countries, turned their attention towards the problem of Ebola. And a lot of that attention was devoted to endemic countries. So one endemic country scientist said to me, during Ebola, a lot of scientists came in. It was quite a chaotic environment. Ebola was exciting for the research community. It is dangerous. Little research had been done. There is no approved treatment. So Ebola had all the right reasons to attract international researchers to Sierra Leone. And I heard over and over again that it was quite a chaotic environment. A lot of scientists were coming in for the first time to that region of the world to do their science on the ground. And not only did scientists turn their attention and visit endemic countries, but they were actively searching for local collaborators to assist with their field work. So another West African scientist said to me, you can't just go to a place to conduct research. They, and he was talking about the foreign researchers, were trying to attract locals, therefore, to help them and to work together with them on their new projects. So these scientists from all around the world, and particularly OECD countries, were flooding into these endemic countries, bringing resources, knowledge, and visibility with them, and looking to create these new ties with these endemic country scientists who were, up until this point, pretty much left out of the global scientific network. So I evaluate the impact of this new tie or opportunity to build relationships with more prominent scientists from around the world by virtue of these foreign scientists visiting and paying attention to endemic countries through leveraging the geography of the epidemic. So the epidemic actually only really affected 3 countries, Sierra Leone, Liberia, and Guinea, and these were the countries by which there was the most population movement, which is why they were worst affected. While at the same time, other extremely similar ex-ante countries around the edge of the focal countries were left largely unaffected, just because of the movement of the virus and the movement of people. So I compared changes in publication outcomes each year of endemic country scientists before and after the outbreak to that of matched control scientists in non-endemic countries in a difference and differences framework. And I used individual sample scientist fixed effects to account for underlying differences of the scientists, as well as a flexible function for career age and calendar year. So because there's no existing database on African scientists, I scraped the full set of biomedical scientist IDs and associated publication record given by Elsevier Scopus, and extract these IDs that were affiliated with a West or Central African institution in more than 75% of their publications between 2010 and 2014, so the 4 years prior to the epidemic. And from there, I narrowed down those scientists who are affiliated with endemic country institutions, and I call that the treated sample. And so this leaves me with 52 treated scientists. So I then find each treated scientist a closest match or matches, so it's a 1 to n match process from the entire set of scientists affiliated with non-endemic country institutions in West or Central Africa. And I do this by using a cause and exact matching procedure so that I guarantee balance on pre-epidemic rates of publication, international collaboration rates, and then some country level features like GDP and size of scientific workforce. So this procedure throws out a lot of non-endemic country scientists in the sample and leaves me with 250 non-endemic country scientists to account for what would have happened in the absence of the opportunity to build relationships with more prominent affiliates. And from this sample of treated and controlled scientists, I take the publication record 4 years prior to an epidemic, the epidemic, and 5 years after, of each scientist, giving a balanced panel data set at the scientist year level. And I use the publication records each year to create annual variables for each scientist on their publication rate and type and collaboration rate and type. And in addition to this quantitative data set, I complement the quantitative data with qualitative data that are gathered during interviews and field work across endemic but also non-endemic countries over the last few years. Okay, so just a first stage showing why this treatment definition of endemic countries versus non-endemic countries seems to be appropriate. So I plot here the average number of Ebola publications co-author with OECD scientists per scientist in endemic and non-endemic country sample. So the epidemic hit in 2014. As you can see, very few non-endemic country scientists published in Ebola, and there's very few publications without OECD scientists in general. So it's not, that's not the difference. It's just non-endemic country scientists just didn't work in Ebola. And this is consistent with my field work that the attention was very much focused on those 3 highly endemic countries at the center of the epidemic. So before I get to my regressions, I'll just show you some of the raw output of the endemic and non-endemic country scientists' average quality adjusted publication rate before and after the epidemic. So this is using a journal impact factor quality adjustment for each publication. So as you can see, before the epidemic, scientists from endemic and non-endemic countries are on pretty similar trends. This is a difference in 2013 isn't statistically significant. But after the epidemic and starting the year off, with there's endemic country scientists experienced this huge rise in the output, which dropped slightly, but appears to be sustained 5 years after. So this rise is consistent with my fieldwork that, as we're seeing now, journals were actually fast-tracking publications on Ebola. So it's not a surprise that the rise in publications happened the year of Ebola and afterwards. And I attribute the dip after 3 years as a shift away from Ebola publications, which were very high profile, back to normal publications, but it's showing some persistent effects, which I'll show in the regressions as well. And similarly for the rate of new OECD collaborations, so I plot the rate of generation of new OECD collaborators for endemic and non-endemic countries sample scientists. And as you can see again, they're on very similar trends prior to the epidemic, but the year of the epidemic and for after the 5 years afterwards, you can see the endemic country scientists experience this huge increase in the rate at which they form new collaborations with OECD-based scientists. Okay, so on to the results of the regression. So I find that this is the results of the difference in differences regression. I find that after the epidemic, these endemic country scientists experience an increase in publication output as compared to matched control scientists, but this is particularly on quality margin of publications. As you can see when I adjust the publications by journal impact factor in column 2. And this is consistent. The scientists said to me, oh yes, well now we've got our Nature publication. So it wasn't so much the quantity, but rather the quality of publications that they're engaging in. And as for the magnitude of this increase, so this increase in publication output from column 1, although not statistically significant, it's quite economically significant. So this amounts to around 1 additional publication per scientist in the 6-year period following the epidemic. But given that a baseline sample of scientists publish less than 1 publication a year, this is a large percentage increase in their output. And as for collaborations, so following the epidemic, endemic country scientists experience an increase in the rate of collaboration with OECD-based scientists, as shown in column 3. And I show that they are creating, as I showed in the raw data, they're creating new collaborators. And I measured this through the number of new names of OECD-affiliated scientists showing up in a sample scientist publication record in a given year. Okay, so although this average effect is interesting, I want to see if there's heterogeneity with respect to who is able to leverage this opportunity, and therefore if we can say anything about the role of these kinds of relationships in inequality in global science. So I split the sample of treated and control scientists into 2 different groups. So those who have any publication in tropical diseases prior to the outbreak and those without.
Sorry, Karen.
Yeah.
There is a clarifying question from Charles. Charles, you want to pose the question directly? I can open you the microphone. Yes, I think it's better.
So I'd love to, I mean, I didn't necessarily mean it as a clarifying question. I just wanted to know, before the OECD authors, if there's like any outliers that you see, like one publication with like 100 OECD authors, you know, with these kind of subjects usually have a lot of. I was wondering if this might be doing it. Just like that question. Thank you.
Okay, I think I heard your question. So my outcomes are all adjusted, they're all transformed. So they're inverse hyperbolic sine. So it shouldn't be an outlier that's driving the results. Also in the robustness checks, I removed the most productive scientists, or these sort of super, like Christian Happy, who made 100 new co-authors either in one publication or in across publications, and the results remain robust to that. But you were talking about, was there sort of one Nature publication with 100 scientists? I don't specifically remove that, so I could try. Yeah, thank you.
Thank you.
Okay, so Ebola is a tropical disease, so it's reasonable to consider that the knowledge required to work on Ebola projects is similar to other tropical diseases, and within institutions, universities and research organizations, usually there's a tropical diseases department where Ebola would sit next to malaria, or even within the same group. So I run the main specification on each of these samples separately, so the treated and controlled scientists who had published in tropical diseases and who hadn't prior to the outbreak. And as you can see, the positive effect of an opportunity to build relationships with more prominent affiliates is driven purely by scientists with tropical disease experience. And in fact, endemic country scientists without such experience, shown in columns 2 and 4, have a decline in productivity following the epidemic. So I'm sure we're all sympathetic to this. The endemic country scientists who weren't working on Ebola projects told me that they had to stop their projects during Ebola due to a stay-at-home order. So that can account for this decline in productivity.
Caroline, another question from the audience. Do you have ER treatment, times treatment regression estimation? Which honestly, I don't know what does it mean, but this is the question.
I can clarify.
Yes, please.
Hi, Caroline. My name is Egbert.
Hi.
I just wanted to, because you have year observations, right? If you could go a little bit back on your slides.
Yes.
You did this on your robustness check, but then, yeah, maybe with the graph, we can see it clearly that we have observations per year. And in your difference and difference regression, you only distinguish between pre and post, right?
With year fixed effects. Yeah, so you don't, yeah, I could show the event.
Specification where, so I think it would be more convincing if you show that the year prior to the Ebola on 2014 doesn't have any statistical significance on the outcomes. And then immediately after Ebola on 2014 and then on, that would have a significant outcome. So I'm basing this comment on this paper from QJE, how potato supported urbanization or something like this. They showed it really well, and I'm asking whether you also have this type of regression.
Thanks, I'll take a look at that paper. I don't have that kind of regression. I have an event study diagram in the paper, which you'd just be able to see visually that there was no statistically significant difference prior to the outbreak. But I could certainly show that as a table as well. I'll have a look at that paper, thank you.
Please go ahead. Thanks.
Okay. Right, so next I split the sample into those who have published all of their publications prior to the outbreak with OECD scientists and the rest of the sample. So this is the sample of treated and controlled scientists. And I run the regression separately again. So I choose this definition of prior connections because, as I mentioned earlier, most scientists in Africa have actually worked at some point with OECD-based scientists, but there's a big difference between those who are extended labs of OECD-based scientists, like Christian and Pardis in that example, and those who have just worked ad hoc with foreigners. So I'm trying to distinguish between these two types of scientists as a way to account for those who are more embedded internationally and therefore more likely to benefit from referrals and shared norms that I talked about in my theory. So as you can see, again, the positive effect of the opportunity is driven by scientists with significant OECD collaborator experience, whilst those without such experience remain completely unaffected by this epidemic or the opportunity. And I'll go into my qualitative data as a way to explain a little bit why I think that is the case. Okay, so next I want to know whether prior knowledge and connections can be substitutes or complements for each other. So you might think, oh, I need to know somebody, or I just need to know something, or one or the other. So I split the sample again into 4 different groups this time. So those with both prior knowledge and connections in column 1, those with just prior knowledge but not the connections in column 2, those with just prior connections but not the knowledge in column 3, and the rest in column 4. And so unfortunately I'm getting into very small sample territory now, but you can see it appears advantageous to have both prior knowledge and connections, and almost useless to have one or the other. So very much complements for each other. Okay, so I explore the mechanism driving this relationship between prior knowledge and connections and the ability to leverage the epidemic using my qualitative evidence. And I find evidence that prior connections in particular served as a referral to leverage that new tie. So one US-based scientist described to me how she connected OECD country scientists and African scientists during Ebola. And she said, I got a lot of calls from people at medical schools in the US who wanted to be involved because they thought Ebola research was cool. I think I got more calls than my West African collaborator. People saw that I had the American-looking name, so they thought I must be in charge. And she went on to describe how she connected these people who called her from OECD countries and her African collaborator, so very much through this referral mechanism that I was talking about. On the other hand, I asked some of the less successful endemic country scientists what happened during the epidemic. And one said to me that despite wanting to work with foreign scientists on Ebola and feeling like he had something to contribute to projects he'd worked in tropical disease areas before, he said, no one reached out to me. I don't have anyone to contact. So really a story of not having this in and not having this kind of referral available to him. Okay, so it's all very well having a bump of your productivity, but was it just due to visibility around their Ebola publications, or is there a long-lasting effect? So I explore this using a cross-sectional regression. So for this sample, I just take endemic country and non-endemic country scientists who published with OECD scientists in 2014, 2015. So you can call them like an in-group or people who are sort of somewhat connected in treated and control sample. And I want to see if there are any longer term advantages to being in this endemic country, so having this boost and this opportunity to build new relationships. And so I just compare the outcomes of the endemic country scientists within this in-group sample to non-endemic countries. And as you can see, they don't again increase their rate of so this is just the years 2018 and 19 that I'm looking at. So well after the outbreak was gone and people weren't paying attention to it anymore. So as you can see, the rate of publications isn't actually increased very much. But what did increase was the likelihood that an endemic country scientist is going to be last author on a publication, and particularly last author with an OECD based collaborator. And so this last author position usually suggests that they're principal investigator or hold a grant. And so you can think of this as this endemic country scientist being able to move up the skill hierarchy ladder. And I talked to many of them and asked them why this was the case. And they said, well, during the outbreak, I met all these new people. I had all this visibility because of my research and because of meeting these new people who landed in our country. And then I was asked to be an editor on Nature, and then I won an NIH grant. So they really talked about moving up that ladder. And I also find in column 3 there that these scientists in endemic countries are more likely to have a hit publication. So that's in the top percentiles of the journal impact factor distribution of all publications. So they're more likely to have their Nature or Science publication. And they told me that this was because they'd already had experience in publishing one of these hit publications during Ebola. So they carried over this experience into their longer term projects. Oh, I don't know why this is blank. Oh, that's weird. Okay, well, I think it's my concluding thoughts anyway. I don't know why this is blank. Okay, well, I'll tell you what it was going to say. So to conclude, I find that there is a causal effect of having this opportunity to build ties or relationships with more prominent affiliates, and in particular, an opportunity to build relationships with more prominent affiliates can increase both the rate, but more importantly, the quality of publication output of global scientists. And so prior literature has tried to document this relationship between ties with prominent affiliates and performance, but has had a difficult time teasing apart a causal impact. And so this suggests that the unequal distribution of these opportunities can increase inequality if you think that these opportunities are just given to higher performing or higher potential actors and they're benefiting from it. This could set in motion principles of cumulative advantage. But I do find this other layer of inequality that these relationships or these opportunities can induce, and that's that it's important to have this kind of positioning or ability to leverage these opportunities to one's advantage, and not everybody can do that. And so that suggests another a factor contributing to inequality, and actually it looks like the magnitude of inequality created by this unequal ability to leverage these opportunities is greater than the inequality that's induced by the unequal distribution of these relationships. And so the prior literature perhaps overestimated the value of these relationships because we didn't manage to measure the value, the average value, or the value for those who never managed to convert this into a long-lasting relationship or to their advantage. So this sort of says something about the design of programs designed to promote global science, and in particular promoting equality and diversification of global science. And perhaps we need to think about these two factors. So to whom do we give an opportunity, and how can we help people who get an opportunity to be able to leverage it to their benefit?